Hi, today we're going to be looking at a new soldering station, and in fact this is a new soldering station to the market. So this is one from Metcal, the GT120, and I bought this from Farnell last week for no insignificant sum. It cost about £500 for this. Now, what I normally use is the Metcal MX5200 series of soldering stations. So this is the PS5200, and then you can get various different handpieces depending on what you need. I also have an MX500 in this same form factor. It's a little bit lower power, but this has been my soldering iron for the last 8 years or so. I bought this and did a video, probably one of my first videos, just doing an unboxing of this and a quick review of it, and I've been very impressed with it. And those of you that have ever used Metcal soldering stations will know these are probably some of the finest soldering stations you'll ever use. They're built absolutely like a tank, very reliable, and also the heat delivery is quite incredible. Now, the normal Metcal soldering stations use an RF heating technology. So the PS5200 drives the heating element at 13.56 megahertz, and then it uses the Curie point of the heater inside there to automatically adjust the power into the heating element so that the temperature is always constant. And if you've ever used one of these, you'll know that no matter what you're trying to solder, the heat is just delivered straight in there. The GT120 is quite different. This is using a more traditional technology. It says, according to the literature, that it's using inductive heating, but from what I can see, it's going to behave very similar to the more traditional soldering stations, where you've got a heating element and then you have some soldering tips which you place onto the handpiece, and then that allows you to change the tip that you're soldering with. So a little bit more traditional. It is quite a powerful one. This one is 120 watts, so theoretically we should be able to dump quite a bit of power compared to the 80 watts of these traditional Metcal irons, but I've found these to be incredibly powerful and never had any trouble soldering anything with them. So today we're going to be having a look at this one and seeing how it behaves. So if we take a look at the Metcal website, you can see this is the station that I normally use, the MX5251. This is the system that I've started off with. I have actually expanded it since then, and you can see here this is the soldering iron that comes with it. I also expanded that to the ultrafine advanced handpiece, which is really quite small in comparison. That allows you to have a little bit of extra control where you're soldering with small components. I also have the tweezers as well, which I found quite useful, but all of these things are quite a premium product and do cost quite a lot of money. And the potential downside for a lot of people with these systems is that the temperature is not adjustable. So the temperature is basically set by the cartridge, and it uses the Curie point of the heating element in here to control the amount of power that is being delivered from the power supply that comes with it at 13.56 megahertz. And basically, if you want a different temperature, you actually have to buy a whole new cartridge. And again, if we look at the Metcal website, they've got a data sheet with all of the different tips that you can buy, but you can see there's 5 different series for the MX soldering stations, each with a specific temperature that they're designed to operate at, and basically that is non-adjustable. So the brand new GT series of Metcal soldering stations is Metcal's answer to those that actually wanted an adjustable temperature station. Now, I've only on very rare occasions had to use a different soldering station because I needed that adjustable temperature. In almost all other circumstances, the standard cartridges just do the job and you never need to play around with it. But I thought it'd be interesting to take a look at these because I know there's not a lot of information out about these new units, and they come in 2 different versions. So the GT120 is the 120 watt version, and there's also the GT90, which is the 90 watt version. You can buy the power supply on its own, or you can buy a complete system, which is what I've gone for. So obviously at $545 here, RRP, it is still a very expensive soldering station, right at the premium end of the price market for this type of device. So I'm really hoping that the performance matches the price tag. So the handpiece can be used in a couple of different ways. Basically, the standard configuration is where you have this heater cartridge, which I think plugs into the handpiece. Then you can buy all of these different tips as a cost-effective way of having a range of different sized tips. And then it basically gets held in with one of these collets, a bit similar to how the Heiko stations work. So that is one method to use. The other one uses a heater cartridge with the tip already integrated. Now, unfortunately, I wasn't able to get hold of any of these cartridges. They're all on quite long lead time at the moment, I think because the station is quite new. But here, this should have better thermal conductivity through to the tip. Obviously with this, we've got some thermal resistance between the heater and the tip. With this one, we should get a better performance, but obviously each tip then has the heater integrated into it, and these are a little bit more expensive. I think these were somewhere between £30 and £40 per cartridge. Now, if we compare the handles, you can see the GT120 handle is really quite chunky. Certainly not uncomfortable to use. In fact, some people may prefer that slightly chunkier grip so that you can get a good handle on what you're doing. The JBC one is a bit slimmer, and the Metcal one is obviously my favourite. Now, the other thing is the distance between the handle where you're actually holding it and the tip. And the MX station is excellent because it gives you really good dexterity because you're holding it very close to where you're actually trying to solder. And on these, this part doesn't even get warm, so you can hold it right here for, you know, prolonged periods and you won't burn your fingers. The JBC one, I find, always gets extremely hot despite the heater being up here. It seems to conduct heat back here, and you tend to have to buy one of those rubber grips. It looks like the GT120 sort of has a rubber grip already integrated, and we'll see how that behaves. Obviously, the distance here is quite short. We're getting quite long here with the heater cartridge plus tip combination. Now, from what I can find, if you use the standard cartridge, it has the heater built in, that distance is reduced again and not quite so long. But, you know, some people may not even notice the difference. I certainly find it really useful to be able to have excellent accuracy with the tip of the soldering iron. On the handpiece, we also obviously have a silicone heat-resistant lead, and that is terminated in a multi-pin DIN connector, which plugs into the front of the power supply unit. To power the device, it comes with a universal input Meanwell Medical power supply, 48 volts at 2.5 amps. The Medical is a nice touch. It means we've got extremely safe output here, so no chance of an electric shock. It is class 1, so the tip should be earthed. We can test that in a moment. But I'm surprised it's 48 volts actually. I was kind of expecting a 24 volt power supply, but obviously they've gone with a higher voltage so that they can decrease the size of the heater in terms of the windings. So a very nice touch here to have a really high quality power supply. Certainly no need to swap this out for something safer. This is a really high quality piece of kit. Then we have the cradle for the soldering iron with some space here for your various different tips, and then the handpiece itself fits into here really nicely, so it's a really nice action, grips it quite firmly, and I believe this puts it into a setback temperature so that you're not always running the tip at full power. But this is really quite nice, quite weighty. It's got these slightly annoying rubber feet on them. I have found that on my MX station that these have actually started sliding around over time, but certainly not too much of a problem. You can see here the tips are actually retained when they're inserted into these holes, and then you get your standard soldering pad, solder sponge, sorry, and then you've got your brass pad in here, which allows you to clean your solder tip. So quite a nice little cradle there for the handpiece. And then we have the control unit itself, which was not clear from the website what this was manufactured from. It looked like it might have been some kind of cheap plastic, which would have been quite disappointing. Actually, it's built very nicely. It's all made from metal and really quite heavyweight in construction. So very nice indeed. On the front here, we've got the LCD here, which displays the power level and the temperature set point and that kind of thing. We've got some buttons here to go into the various menus and change the settings. We've got the DIN connector, which goes off to the handpiece. And then on the back here, we've got the USB connector, which I think is for firmware updates. We've got a nice clicky power switch. Obviously, it doesn't turn off the mains. This just turns off the 48 volt input here. That is the input from the power adapter. And then if we take a look at the bottom here, we can see we've got the rating plate. So the GT120, nominal 30 watts, 120 watts maximum. I have serial number only 144, so very early in production here. And this one was manufactured around this time last year. So I don't think these have really flown off the shelf, but then a lot of suppliers don't seem to have stock of these at the moment. Presumably this all started when everything was in full flow lockdown and everything last year. But Farnell was the only place that I could get stock of these, so I bought mine from there. They've still got about 16 in stock, but I don't think these have flown off the shelf, especially at the price point that they're at. Everyone else was asking for sort of 8 weeks lead time, so also that was the case for the soldering cartridge that I was after. We were looking at 8 weeks, and I wasn't willing to wait that before doing the review. But yeah, I think it's still very early in production. It seems that Metcal are releasing all of their promotional material around now. I've seemed to have had a whole load of emails from them, despite the fact that these have actually been out for quite a while on the Farnell website. So we've got the unit all connected up. Let's power it up for the first time. So we've got version, I think it said 0.83, and then we've got the temperature here on the left hand side and the handpiece power, so the amount of power that's being put into the heater cartridge. We've got the model number, GT120, and then it's detected that we're using the heater cartridge in the T6 handpiece. In the menu, we've got things like the various temperature presets, so you can set various presets quickly to allow you to access different temperatures as you need them. We've got some system related things, so we've got the languages, we've got the password which allows you to lock the settings so people can't change the temperature, for example. We've got the brightness, which allows us to change the brightness from 0 to 100% on the display in what appears to be 10% steps. Then we've got the offset, which allows us to fine-tune the calibration of the tip. Then finally at the bottom here we've got the energy management. So I was slightly incorrect. This one doesn't use a magnet and a reed switch to determine when you put it in the cradle. It puts it into standby when it detects no movement. So there is a movement sensor in the handpiece. Then after a given period of time, which you set in the timer, it then drops to the temperature that you've specified in standby temperature. And then finally, if it detects no movement for the amount of time that you put in the sleep timer, anywhere from 1 to 100 minutes, then it physically turns the handpiece off until you next move it, and then it starts ramping up from cold. So from the main screen, we can adjust the temperature just with the up and down arrows. If you hold down the button, it decreases it in 10 degrees C steps. But after that you can press it individually to do the fine tuning. So relatively easy to adjust the temperature within the types of areas that you're going to want to do. And it is fairly responsive. I don't think it's quite as quick as the MX-5200, but certainly the amount of time it takes to heat up shouldn't be a problem for most. So we'll just tin the soldering tip. I've got a bit of solder here. And then we can, it melts as you would expect on the tip, no problem whatsoever. So let's do a little bit of soldering, and then what we might do is just see what the thermal capacity is like and see if we can use one of these higher power tips to get lots of heat into a piece of metal and compare it between the soldering stations. So we've got a little soldering trainer board from JLC PCB, so let's do a little bit of soldering just on a standard PDIP package. So the temperature is set to 330. And certainly I can feel that there's no problem melting the solder on this quite simple PCB. In fact, it solders very nicely indeed. Now what I am noticing is that there is quite a noticeable difference with the soldering when your fingers are so far away from the tip. So it's a little bit more difficult, a little bit more challenging to solder. The MX station feels extremely natural to solder with. I am noticing that extra little bit of length between my fingers and the tip, but in terms of the soldering, it's certainly not presenting any challenge on something quite simple like this. So now we'll try soldering onto something with a lot more thermal mass. So it's only reading about 38% power, so I think the particular tip that I'm using here is restricting the heat a little bit there. Let's try choosing one of the chunkier tips that I've got. So we've got a slightly more chunky tip on here. Let's try feeding the solder in on this pad here. So we'll give it a bit of heat, and then start feeding the solder in. And that seems to flow in there quite nicely. It is bulging up slightly, so it's taken a little bit longer for that heat to get into the pad than I would have liked. And we'll just try it with the MX-5200 and see how we can feed in the solder to one of these pads. So we'll heat it up and then start feeding the solder in. And you can see basically we can just feed in the solder at a steady state, and that just happily goes in there and fills the pad with solder. So really quick on the MX station. Next up we've got a 2p piece, which is a reasonable lump of copper, and we're going to try and solder this on both the GT120 and the MX-5200. So again, this is the largest tip I've got for this GT120 station, and let's start trying to melt some solder on it. And it looks like that's just starting to flow there. So quite a considerable difference there between the output from the GT120 and the Metcal MX-5200. I think this is incredibly quick. I think if we're able to get hold of one of the full cartridges, I think we'll get much better performance. We're somewhat being limited by the fact that we have that thermal resistance between the heater and the tip, but for very high output applications, like if you're trying to do this solder test, there's just no comparison to the all-in-one cartridge from the MX-5200. So I think obviously the next thing to do is let's have a look inside the control module. Now it looks like we can get access to all of the screws. So I'm going to start by first of all taking this bottom panel out and seeing what we can see from here. So underneath the bottom panel, there's not actually a lot there. So we've got the power coming in on the DIN connector. It's obviously connected nicely to earth. The whole chassis is earthed there from the power supply. Got a couple of big chokes, presumably to soften the edges on the switching waveform. Presumably they're PWM controlling the heater. But not a huge amount on the PCB on this side. So I can only see a couple more retaining screws, so we'll try undoing these and see if we can get any further. Ooh. The LCD is not very well retained there. Just trying not to break anything. So we've got our chassis earth onto the front there. We've got the LCD itself that has a little flexi ribbon. And let's see if we can have a look underneath here. Just give me a moment. So here we have the main board. You might just be able to make it out there. The microcontroller at the centre there is a PIC32 MX250F256H. So quite a powerful microcontroller for this system. I suspect the majority of that is actually being used to drive this graphic LCD. The controller certainly doesn't need all of that processing power to be able to do the control. We've got the header on the left hand side here off to the LCD with a whole bunch of tantalum capacitors around it. We've obviously got the programming header here off to the PIC32. On the back, all I can see down the bottom is a DC to DC converter. You can just about make it out there. So presumably that is dropping the 48 volt input down to something more reasonable for the electronics on the board. And then we've got our switching device, so just a MOSFET here for the heater. So clearly they're PWM controlling the heater, and then they've got these inductors here to smooth off the edges. Now, somewhat surprisingly, we have a bit of a bodge here. So we've got a isolated DC to DC converter, which appears to be being fed off from one of the pins over here. These two op amps here are LTC 6088 high precision, low noise, low offset voltage, low drift op amps, really nice devices, but it seems to be tagged on to something here. So I don't know if this is to do with the temperature sensors. Maybe they had some issue with the voltage rails and the bias on there. I don't know, it looks like it's associated with that in some way, so maybe they had to isolate the temperature sensors from the rest of the electronics. But a little bit disappointing to see a bodge on there, but it is all stuck in place fairly well. I guess as a very early production unit, there probably are going to be some issues. Unfortunately, I've not got a revision of the PCB where this is all fixed, but it all seems to work okay. It's just a bit of a shame that they've bodged that on there to this connector at such a high price point on this device. Now also, it does look like we've got a serial output here. It says debug port. Maybe there is some serial stuff that you can do with there, some diagnostic or other information. Other than that, there really isn't a lot on here, and I wouldn't necessarily expect there to have been, because all we're doing is driving a heater, reading the temperature back, driving an LCD and interfacing with these buttons. It's not doing a lot, but then you do have to ask yourself about that price point and where all of that money is actually going. So you might just be able to make out there, we've got a little microchip 3-pin linear regulator for the microcontroller. Then you can see that DC to DC converter at the bottom that I was talking about. There's a little SOT23 6-pin package, but I can't quite see what it is. And then there is one more DC to DC converter here, the TPS54360 buck regulator. You can see we've got our input caps, we've got our diode, we've got our inductor there, and then a couple of large electrolytic capacitors on the output there. So that is basically all that's in this device. So you might be a little bit disappointed with what's inside the control unit, but really it doesn't need that much more electronics to work. And in fact, the performance is not going to be hindered by the fact that this is quite a simple device. All of the performance is down to the heater cartridge and that kind of thing. Now, just as a comparison, we've got the JBC soldering station. I've just got this webpage up from the EV blog forum. This is inside basically a competitor model, so this is the JBC CD series of soldering stations, and that one also uses a microchip part. And although there looks like there's quite a lot on here, this also has some of the power supply electronics in here. Now, what you've got to remember is Metcal have decided to use the external power brick, and then they're feeding in 48 volts. This one, if we look further down, does have a standard transformer, which is where a lot of the weight is in one of these units. But then you've got all of the voltage regulation and everything to do with that all built into here. Now, there is apparently a little bit more electronics in here. It can detect, for example, when you've got the tip in the bit where you actually extract the tip, so it can detect when you're changing it and all that kind of stuff. So it is a little bit more functional, but the Metcal unit does still detect when you're taking out the cartridge and swapping it over and that kind of thing. So that is all built in, and presumably they've found some other ways to do all of that. Now, in terms of the performance, I think really I need to get hold of one of the integrated tip heaters cartridge units, because I'm not really getting the full performance to do a comparison as to how much heat we can dump into something with this arrangement. You could see there's a quite clear difference between the MX5200 station and this one, but for general purpose soldering, you know, there's absolutely no problem with it. And in upcoming videos, we're going to use this and see how we get on with it, and I'll probably do a 1 month or 2 month review on this device once I've had a chance to use it a little bit more. So that is a little look at the Metcal GT120 station. Certainly not a cheap device, and probably also not going to be the first choice for many. And for me, I think it's an interesting device, and it's certainly going to get used on my bench, but I can't help but think that all of Metcal's magic was in the RF heating of those heating elements and the super fast control loop, and just the fact that you can always dump power into your PCB when you need it, and then when you're doing something more delicate, without changing any settings, it just works as it should. The variable temperature thing has some useful instances where you're needing that particularly low temperature, or maybe even a high temperature for something very specific without wanting to buy new cartridges, but we're getting more into the realm of all of the other devices on the market, and then that's a much more competitive market. Obviously we've got those cheap Chinese units, the KSGR unit, which I really quite like, and is available for 1/10 of the price of this unit, and really it's probably going to 99% of the time perform exactly the same. I really want to get hold of one of those cartridges, so I'm going to place an order for one, unless Metcal want to send one to me. I'll place an order for one, and maybe in 8 weeks' time when it finally turns up, we'll do another comparison and just see whether that allows us to dump that extra power into the PCB. But as there wasn't a great deal of information about this device out here, I decided to buy one for this video. Hopefully, if you were thinking about it or were intrigued by this unit, you found this video useful. Also, if you've got any suggestions or something that you want me to try with this unit, then leave it in the comment section down below, and I'll do my best to accommodate those requests. So hopefully you found this video useful. Big thank you to JLC PCB for being my video sponsor, and until next time, thanks for watching.